Good morning, Year Nines. I am Mr. Vincent. Hope you're all well and staying safe. Today's lesson will be looking at how do we use equations effectively in physics. Feel free to do it several times before attempting the quiz. Also, before we proceed, please make sure you have a pen, a ruler, a calculator, and a few blank sheets of paper, whether ruled or plain is fine, so that you'll be able to practice the questions as you go through the slides. Now pause the video and go and collect all the equipment, more especially a calculator. Good, hope you've got everything. Now, let's try out these starter questions numbers 1 to 5. Pause the video and attempt these questions before proceeding to the next slide. Now, let's answer this question. The first question asks you about renewable sources of energy. What are they? They are sources of energy that can be easily replaced or replenished. Those are the keywords. They have been underlined for you. Replaced, replenished. If you had used the word reused, you would not score any marks in an exam. So therefore, don't use the word reuse because they say renewable. You have to use the word replaced or replenished in a short time. The second question was to give examples of renewable resources of energy. I have given all 7 which we've studied. Any 5 of the 7 is fine. Now, the third question is non-renewable sources of energy. They are sources of energy that will run out. Just words, those are the keywords in the answer, will run out. Now, the next question was to give 2 examples of non-renewable sources of energy. Of course, it's fossil fuels and nuclear fuels. And the last one was an advantage of biofuels is that biofuels are carbon neutral. We mean carbon neutral because the carbon dioxide absorbed by the plants is equal to the carbon dioxide released into the atmosphere when the fuel is being burned. That's why we say it is carbon neutral. Okay, hope you had all of them correct. Now let's proceed with the lesson. In today's lesson, we're going to be looking at some physics equations you should be able to recall and apply. When you will be doing your GCSE, AQA requires you to know about 21 equations, or if you're doing higher tier, 23 equations that you shouldn't be able to recall and apply in an exam. Not only recall and apply them, but of course, in applying them, you should be able to rearrange these equations to make a different variable the subject of the formula. And finally, when writing your answers, you write them using standard SI units. The first equation we're going to be looking at is the equation we studied in year 8 when we were studying forces. When we were studying forces, we studied the equation weight equals mass times gravitational field strength. Now, just a quick reminder, we know people get confused between weight and mass. They get it mixed up. Weight of an object is the gravitational force between the object and the earth, whereas the mass is the amount of matter something is made up of. So, the weight of an object differs from one planet to the other. Your weight on Earth is different from your weight on the Moon, is different from your weight on Jupiter. On Jupiter, you weigh far more than you weigh on Earth because the gravitational field strength on Jupiter is far greater than the gravitational field strength on Earth. However, your weight on the Moon will be less than your weight on the Earth because the gravitational field strength on the Moon is less than the gravitational field strength on Earth. Your mass is the same everywhere. Wherever you go, your mass on Jupiter will be the same as your mass on Earth. It will be the same as your mass on the Moon. So the mass stays the same. Now, so we're looking at this equation, weight equals mass times gravitational field strength. We use W to represent weight, M for mass, and G gravitational field strength. So your equation can be written as W equal mg. Now the weight is normally measured in newtons because it is a force. Your mass is measured in kilograms and gravitational field strength is Newton per kilogram. Please note these standard SI units. So if you give a mass in grams, then you have to convert the mass to kilogram. Now let's look at an example. It says Christy has a mass of 60 kilograms. Calculate Christy's weight on Earth if the gravitational field strength is 10 Newton per kilogram. For GCSE, I would like to remind you, for some GCSE questions, they might tell you that the gravitational field strength is 9.8 Newton per kilogram. For this course, I've used gravitational field strength is 10 Newton per kilogram to help ease the burden of calculating. So the first thing we do, we recall a formula: weight equals mass times gravitational field strength, or we use the short form W equal mg. Look at a question and look for the mass. The mass is 60 kilograms. Again, we look for a question and find the next variable that is given, which is 10 Newton per kilogram, and we know it's the gravitational field strength G, which has that value. We've got a mass, we've got G, we simply substitute into the equation and multiply the two values. So 60 multiplied by 10, and that gives us 600 newtons. Don't forget, weight is a force, so therefore we need your SI unit, or we need the SI unit newtons to be written after your answer. Here is one for you to practice. It says Adam is on Earth where G is 10 Newton per kilogram. He has a mass of 85 kilogram. What is his weight? I'll allow you to pause the video at this point, have a go yourself, and then return to the video and continue and to find out the answer. Pause at this point. Right. Hope you've tried it out and you didn't find it difficult to do. Right. The mass is 85 kilogram and G is 10 Newton per kilogram. Use an equation weight equals mass times gravitational field strength, or just simply write G. We've got a mass of 85 kilogram and a G of 10 Newton per kilogram. Substitute into our equation. We have 85 multiplied by 10, which is 850. Don't forget your units, newtons, N. Right, here's some more practice questions for you to try out. Pause the video and have a go. Right, let's look at the answers now. The first one should be 1 Newton because it's 0.1 kilogram multiplied by 10 newtons. The second is 30 multiplied by 10. The mass is 30, G is 10. The third one, M is 40 and G is 10. So 400 newtons. Hope you had all three correct. If not, I suggest you go back, go through those first few slides and attempt them again and see if you get the answers. Now, the next thing we want to do is we want to start rearranging this equation. And the first variable we're going to rearrange for is G. So assume you're given a question wherein you have the weight, you're given the mass, but they say find the gravitational field strength. So they might give you the weight of somebody on the moon, and they give you the mass of the person, and they say find the gravitational field strength on the moon. You can use your formula W equals mg. So we are rearranging to make gravitational field strength G the subject of the formula. We first of all write the short form of the formula W equal mg. We will notice that we have mass and G on the same side, but we want the equation to be in such a way that G is alone on one side. And therefore, what do? we divide both sides by m because we need to get rid of this m. We need g to be alone on one side of the equation. So dividing both sides by m, this is what we'll get. Now, after dividing both sides by m, you'll notice on the right-hand side of the equation, we have m in the numerator and m in the denominator. So the m's will cancel out. And then we're left with w over m equal g. We just rearrange the equation such that g is on the left. So it will be g equal w divided by m. And that's how you make g the subject of the formula. So, as usual, let's practice a question. So, on the moon, Christy with a mass of 60 kilograms would have a weight of 100 newtons. Calculate the gravitational field strength on the moon. The formula down, the short form, and then let's rearrange the formula. Of course, G equals W over M. If we go to our equation, we see that we've got W 100 newtons. Sometimes even the units will help you to tell you which variables have been given in the question. So we have 100 newtons, we know that is the weight. We have a mass of 60 kilograms. So we have the weight, we have the mass, we simply substitute in an equation. The weight 100 divided by 60 gives us 1.67 Newton per kilogram. Don't forget your units. And so that is your answer. On the moon, G equals 1.67 newtons per kilogram. The next thing we want to look at is how we rearrange the equation to make M the subject of the formula. So assume you're given a question. In the question, you have weight, you have gravitational field strength, and you need to find the mass. W equals mg. We're going to rearrange to make mass the subject of the formula. As usual, we write the formula down, W equal mg. Again, on this side of the equation, we have m and g, but we want m alone on this side. So we need to get rid of the g. Hence, we have to divide both sides by g. Having divided both sides by g, you'll notice that on the right-hand side of the equation, we have g in the numerator, g in the denominator. So the g's will cancel out. Having cancelled out the g on the right-hand side, we're left with w divided by g equal m. All we need to do, rearrange the equation such that the m is on the left-hand side. So we have m equal w divided by g. And that is how you rearrange the equation to make m the subject of the formula. Let's practice a question. It says Chris weighs 730 newtons. Calculate his mass if the gravitational field strength is 10 newton per kilogram. Again, you quote your standard formula, weight equals mass times gravitational field strength, or you can simply write the short form, W equal mg. Rearrange your equation to make m the subject of the formula because we're given the weight 730 newtons, we're given g gravitational field strength 10 newton per kilogram. We are asked to calculate his mass, so that's how we know we need to make m the subject of the formula. We've just done that on the previous slide, so we know that m equal w divided by g. Substitute your values into the equation. W 730 for w and 10 for g. Your division, we know that the mass of Chris is 73 kilograms. Don't forget your units. Now, want to look at another equation called the distance time equation. This as well you studied in year 8 when we studied motion. So distance traveled equals speed times time. So speed, the distance traveled is represented by S, the speed is represented by V, and the time is represented by T. Distance traveled, the unit is meters, speed is represented by meters per second, and time is represented by seconds. We want to rearrange this equation such that to make the other variables the subject of the formula. And the first one we're going to make the subject of the formula is V, speed. The equation given to you is distance traveled equals speed times time. So assume you have a question wherein the distance traveled by the object is given and the time it takes to make that journey is given. However, we want to know at which speed did that object cover this distance. So we use the equation to make speed the subject of the formula. And speed is represented by V on the right hand side. We've got T next to the V. We need V to be alone on this side, so we need to get rid of the T. How do we do that? We divide both sides by T. Once we've done that, you'll notice that on the right hand side of the equation, there's T in the numerator, T in the denominator. The T's cancel out, and we'll be left with S divided by T equals V. All we need to do is just rewrite the equation such that the V is on the left, speed is on the left, equal distance divided by time. Now let's look at the other way we can rearrange. Now we're going to rearrange the equation for time. S equals Vt. S is for distance, V for speed, T for time. Rearrange it such that time is the subject of the formula. Again, we write the standard equation. We notice that the V and T are on the same side. I believe by this time a lot of you will be saying these words alongside me. So what happens next? Divide both sides by V. You're correct. We divide both sides by V. This is what we'll get. We find out that V's on the right hand side, there's V in the numerator, V in the denominator, so the V's cancel out. Now the V's cancel out, you're left with S divided by V equal T. All we need to do, rewrite the equation such that T is on the left. Right. Here are 3 questions for you to practice. I have deliberately placed them on this one slide because I want you to find out, based on the values given to you in the questions, which equation to use. So they're all jumbled up and you need to choose the right equation for the question based on the variables given. Pause the video now and have a go. Right. Believe you've had a go at these questions. Let's look at the answers. For the first one, it says a cyclist has an average speed of 8 meters per second. Calculate the distance the cyclist would travel in 20 seconds. So, solution, we write a speed distance traveled time equation. Distance traveled equals speed times time. We write, or you write the short form, whichever you use is fine. What is given in the question? We're given the speed in the question, 8 meters per second. We're given the time, which is 20 seconds. And so we have to find the distance. It says calculate the distance. So you've got the speed, you've got the time. We use the equation as it is. We just substitute 8 for V, 20 for T, 8 times 20, 160, and the unit for distance is meters. So with a speed of 8 meters per second for a period of 20 seconds, the cyclist covered a distance of 160 meters. Now the next question. It says a car travels along the motorway at a constant speed of 70 miles per hour. Calculate how long it would take to travel 175 miles. And from the question, you'll find out that the car traveled along the motorway constant speed. We're given speed and we're given distance. It says 175 miles. So we asked to calculate how long, which means we're asked to calculate or find the time. So we rearrange the equation to get time equal distance divided by speed. We've got distance of 175 miles, speed 70 miles per hour. So we substitute into our equation 175 divided by 70, and the answer is 2.5 hours. At this point, let me remind you, 2.5 hours is 2 hours 30 minutes, not 2 hours 50 minutes. Please remember we're dealing with time which is out of 60. Final question is, the new HS2 high-speed train is expected to complete a journey from Birmingham to London in 50 minutes. The distance the train will travel would be 120 miles. Calculate the speed of the HS2 train. So we know we're calculating the speed, we're finding the speed, we're given time 50 minutes, we've given distance 120 miles. We write our equation, we arrange it. Because of space, that's why I've written the equation, the rearranged form of the equation directly onto the slides. But in the exam, you might need to show working how you rearrange the equation to get to this expression. So the expression is V equals distance divided by time. Speed equals distance divided by time. As I said, we're given the distance 120 miles. We're given the time 50 minutes. However, it's nice to work in the another standard unit, which is miles per hour. So we have to convert 50 minutes to hours by dividing by 60, because 60 minutes make 1 hour. So we divide by 60. And hence, we get 0.33 hours as our time. So the speed is 120 miles divided by the 0.833 hours, and the answer is 144 miles per hour. That is quite fast. Okay, hope you understand everything we've gone through this morning. If not, I suggest you go through the slides again. Make sure you understand them, the content, before proceeding to do the quiz. If you're sure you understand what we've covered so far, then please feel free to move on to completing the quiz. Thank you.